Let's take a look at this identity. I see squareds, I see to the fourth, I see cosecant, I see cotangent. So whenever I see these terms and they're raised to powers, that makes me think of a Pythagorean identity. The identity is 1 plus cotangent squared theta equals cosecant squared theta. Alright, now usually with an identity we want to work with the more complicated side. Here they're both about the same, so you can pick and work with either side. I'm just going to work with the left side because the way that identities are written, most of the time you just work with the left side. That's how they're presented in the book. So now I do have a problem here though. I have a cosecant squared. That's good. So I am going to be able to take my identity here. I'm going to be able to take this part and plug it in for my cosecant squared. And there is a minus in front, so when I plug it in, I'm going to have to plug it in parentheses. But that doesn't help me with this first term here. Not directly, anyway. This is cosecant to the fourth. I need to somehow make this cosecant squared. How can you make something to the fourth squared? I could think of it like it was cosecant squared theta raised to the what? Second power. Because power to a power you multiply. If I think about this first term like it's cosecant squared squared, then I can take the 1 plus cotangent squared and plug it in parentheses there. And so what that's going to do is that's going to change all of my cosecant squared terms over to cotangent terms. Let's see if that works. So I'm going to plug in 1 plus cotangent squared in these two places. So 1 plus cotangent squared theta squared minus 1 plus cotangent squared theta. So I plugged it in those two places. Now I need to simplify this. I need to square 1 plus cotangent squared. You don't just square the first term and the last term. You're saying this thing times itself. So you have to FOIL it out. Alright, here I have a minus in front. I just need to distribute that minus. So it's going to be minus 1 minus cotangent squared theta. Now let's multiply that out. You're going to get 1. Then you're going to get a positive cotangent theta. You can get another positive cotangent theta. So that's going to be plus 2 cotangent theta. And then you're going to have cotangent theta times cotangent theta. That's cotangent squared theta. Then you have minus 1 minus cotangent squared theta. Okay. I have a plus 1 and a minus 1, so they cancel out. I have a plus cotangent squared theta and a minus cotangent squared theta, so they cancel out. Is that right? That's right. Seeing if y'all see that. When you say, I'm saying cotangent squared, 1 plus cotangent squared squared, so this needs to be squared, and this needs to be squared. Oop, right there. So that would be 2 cotangent squared theta. That would be, is it 2? It's just cotangent. Okay. So I still need to put these together though. This term here and this term here are like terms. So if you didn't catch that, wake up. The good thing about identities, I mean there's a lot of bad things about identities because they are a little confusing here and there. But the good thing is you have a direction. You know where the problem wants you to go because you want to get to cotangent to the fourth theta plus cotangent squared theta. So on this problem right here, you see how I was working it out and then I made a mistake and then things started canceling out and I wasn't getting what was on the right side? Well, that's when you know that either 1, you've made a mistake, or 2, you're not going in the right direction. Alright, so keep that in mind. You always want to see your goal or what you're shooting for. You always want to look at that and kind of act as a guide for you. Whatever your identity is equal to, that's what you want to work towards. And it's easy to make a mistake. Just one little small mistake and then your whole problem is shot. Alright, let's look at another problem. Cosecant of theta minus cotangent of theta equals sine of theta over 1 plus cosine of theta. Now both sides look about equally as complicated, but working with the right side, there's not a whole lot I could do other than maybe multiply by a conjugate. And that's just going to give me something that looks similar to the right side. So let's try to work with the left side first. You say, what could I do with the left side? I have a cosecant term and I have a cotangent term. So whenever I have those types of terms, I usually try to write everything back in terms of sine and cosine and see where that gets me. Cosecant theta is 1 over sine theta. Cotangent theta is cosine theta over sine theta. So if I got a common denominator, they already have a common denominator. Their common denominator is sine. You don't say sine times sine. It's already sine. So the terms that go on the top are just the terms that are in the numerators for both terms. So 1 minus cosine theta. Now that does look similar to the right side, but that's not the right side, is it? So whenever I have a fraction that I have a trig function and I have another term with that function in the numerator or denominator, one common thing to try is multiplying by the conjugate. Let's see if that'll rewrite this for us or put it in another form for us. The conjugate is 1 plus cotangent theta. 1 plus cosine squared theta. Sorry. The conjugate is 1 plus cosine theta. So I want to multiply the numerator and denominator by 1 plus cosine theta. So that means I'm going to have multiply out the top. Remember, when you multiply conjugates, you can just multiply the first term and the last term because the middle terms always cancel out. So that's 1 minus cosine squared theta. I'm not going to multiply out the bottom. I'll show you why in just a second. I noticed that the top here, this 1 minus cosine squared theta, that looks familiar. Yeah, that's a Pythagorean identity. That's equal to sine squared theta. So I can now rewrite that as sine squared theta over sine theta times 1 plus cosine theta. If I do that, this sign here cancels one of those signs out, and I'm left with sine of theta over 1 plus cosine of theta, which is what I have on the right side of the equation, so I've established the identity.